So welcome to the engineering math class 1 for spring semester. My name is Doyeol An. Sorry, I don't actually like a black color. So I'll be guiding you through the semester for the world of engineering math. And so this is my email address. So if you have any questions or if you want to consult something, you can always send me an email. And prerequisite for this class is the typical calculus. Just in case, anybody who hasn't taken calculus, 미적분학, raise your hand. So at least everybody knows how to differentiate and integrate, right? So sometimes that's great. So that's okay. I think your primary concern is my grade policy. So what kind of grade you will get after the semester. So my grade policy is only one. A plus 10%. So we have 105 students, so approximately 11 students will get A plus. That's the only criteria I have. I think I'm quite generous for the A, so maybe 35%, 40% usually get an A. And usually I don't give you homework. I mean, homework to submit. I gave you some homework, but homework is just you do at home. But do not turn in. So I usually give a homework like several problems per week. So that homework is usually I ask you to actually do at your home. But you don't have to submit. Because I usually found that about when I collect the homework, then usually 20% of the students do the homework, and the rest copy those. So can you send? But the merit of doing homework is usually those homework problems, those problems I give you at the midterm or final or quiz. So just usually you can prepare for the quiz, to prepare quiz or final. Usually I don't have a midterm. 중간고사는 없어요. But instead, probably 2 or 3 quiz, 1 or 2 hours, and 3-hour final. So quiz covers about 60% of the total grade, and final about 40%. I don't usually check the attendance. 출석은 안 불러요. But instead, there may be a surprise quiz without pre-announcement during the class. And maybe 1, 2 surprise quiz. Usually 10 minutes. And so during the whole semester, I might have 1, maybe 2 surprise quiz. And if I announce surprise quiz, I usually lock the door. So if you happen to be here, then you're fine. If you're not happen to be here, then maybe you have bad luck. But just a small point, maybe 10 or 20 points, so that you can just think of it as a attendance point. 출석 점수. So before I proceed, any questions about the grade policy or homework or whatever? And of course, the English is the official language, so I'm going to use English as the main means of lecture. Maybe if you are not familiar with some special words or jargon, maybe I can translate those words in Korean. But otherwise, you can just assume that everything will be done in English, including the quiz problems. And I encourage you to use English when you write down your answer sheet, but it's not required. So you can still use Korean for your answer sheet. And am I loud enough? I mean, can you hear me at the back? If I speak too fast or too slow, just let me know. Then I can maybe adjust the speed. And after each class, I usually upload my class into YouTube. So you can check David An is my English name, with the title Engineering Math. So after each class, I usually upload, maybe tonight or tomorrow, to the whole class. And one thing I need to apologize before upload the classes. Usually my YouTube class lasts about 2 hours. I mean, these days, 15 minutes is standard, right? Every YouTube, just 15 minutes, 15 minutes. In order to do that, I have to edit, but I don't have time. So I'm just going to upload the whole bunch of my class. So it's going to be about 2 hours length. Thank you. And also PDF file. So PDF file on my TA, Mr. Park. Why don't you stand up? So you can say hello to them. So he's going to manage the whole class during the semester. And after the class, YouTube I'm going to upload myself, but PDF file, Mr. Park is going to upload. So he's going to put the site name, right? Do we have a site name here, or? All right. So he said we have an online lecture room. Seoul. So PDF file you can found out there. Also all the previous quiz problems as well, I think. I hope. So far we have 105 students. And I believe 4 exchange students. So during the break, I'm going to put the attendance list on the table so you can check whether your name is in the list or not, right? It happened once about 10 years ago. One of my students went through the whole semester, taken every quiz, final, even got a good grade. But when I was going to put his name, grade on the computer, his name was not there. So he didn't bother to check whether his name is on the list. So I think for your own benefit, you should check. So the main topic for this semester is linear. So linear algebra is a subject that deals with the matrices. So matrix is a collection of numbers in a square form, like A, B, C, D, or A, B, C, D, E, F, G, H, I. The matrices is a collection of numbers in square form. And usually the horizontal arrangement of numbers is called row, and vertical arrangement is called column. And matrix is defined by the number of rows and columns. So say 3 by 3 matrix is the number of row and the number of column. So sometimes this number is called dimension of the matrix. So simple quiz, what is the dimension of this matrix? How many rows this matrix has? 2, right? Very good. How many columns? 2. The dimension is 2 by 2. We say 2, 2. And we say by. So 2 by 2. And this particular form is called the square matrix. Some matrix has different number of rows and columns. For example, so what is the matrix? How many rows does this matrix has? 2. How many columns? 3. So in this case, we call 2 by 3 matrix. by 3. So this is the rectangular form. Matrices satisfy several interesting properties called 4 algebraic operations. 4 algebraic operations. This is the most fundamental operations of mathematics. Very basic and most fundamental. And probably you know everything already. Number 1, addition. Sometimes we write this way, right? Second, subtraction. Or you can write down this way, right? Multiplication. Of course, this by cross, right? And finally, division. And if you have a particular set of numbers, if a particular set of numbers satisfy all 4 basic arithmetic, algebraic, or sometimes arithmetic operations. We say the set is closed for 4 basic arithmetic operations. I probably need to make another apology that my handwriting is usually just flying. So you may times adjust to my handwriting, but I hope it's not that bad. So if we have a set of numbers, some set with particular numbers, and if you can have all those 4 operations and the results are still in the same set, then we say the set is close to the 4 basic arithmetic operations. So let me check with some number systems. The first number system that you learn in your life is natural numbers, right? 자연수. So natural number system actually was known to us for a very long time. I think probably maybe up to 100,000 years, maybe before. Since so it 1, 2, 3, 4, etc. Right? Natural number system you learn in the first grade. Start with the 1, 2, 3, 4, 5. And actually 10, 11, etc., etc. So basically we are using base 10 numbers. 10법. And maybe known to us for over 100,000 years. So it dates back when there was a caveman who hunted for the rabbit, right? Sometimes two rabbits. And there was near the sea, there were fishermen, right? They catch fish. So cavemen eat rabbit all the time, sometimes get bored. Fishermen eat fish all the time. Sometimes they like try rabbit, how to do this rabbit, right? So one day they decided to make an exchange in the middle. So what they do, one rabbit for one fish. If there is more than 5 rabbits, how do they count? So one rabbit, 5. If there are more than 5, you can use another hand, right? 6, 7, 8, 9, 10. What happens if you have more than 10? You bring your friends, right? Use these hands to count additional numbers, right? So that's how our number system is based on 10. Instead, if 65 million years ago, the comet didn't hit Earth, and somehow dinosaurs survived, and they might evolve into intelligent beings, right? So there were cave dinosaur and fishing dinosaur. They might exchange the fish and the rabbit. How many fingers dinosaur has? 3, right? So in that case, they have 6 fingers. So in that case, if instead was, if the descendants of dinosaurs are teaching and taking class, or the 3 fingers will be a dinosaur. So we have only 3 fingers, right? Then our number system would be based on 6, right? Base 6. Anyway, so that happens maybe 100,000 years ago, or maybe 65 million years ago. I don't know. The history maybe has developed into 2 different directions. If something didn't hit Earth, then maybe we didn't have a chance to evolve. Instead, dinosaur, maybe velociraptor will teach engineering math. Then we are going to talk about the basic number systems. Anyway, the natural number can be added together, right? So we say natural number as n, set of natural numbers. So 1, 2 belong to natural number. If we add them together, what happens? 3. Still natural number, right? We can multiply 2 by 3. Still natural numbers, right? Subtraction. 1 minus 2. It doesn't belong to natural numbers, right? One divided by 2 does not belong to natural numbers. So natural number system is not close to 4 basic arithmetic operations, but instead only close for addition and multiplication. The next number system is integer. Integers consisting of -1, -2, 0, 1, 2, etc., etc. So integer is a natural number with a 0 and a negative of a natural number. And integer system has been known to us for, I don't know, for a long time, at least 3,000 years. So you can add 1 plus 2, 3 is integer. 1 minus 2 minus 1, still integer, right? 2 by 3, still integer. 2 divided by 3, does not. So integer system is close to addition, subtraction, multiplication, but not division. The integer system is not close to the 4 arithmetic operations of gain. Rational numbers. Q is defined by n, m. N divided by m. So n and m both belong to integer. And m is not equal to 0. Then obviously, the rational number system is close to 4 arithmetic operations, right? Because you can now define the division. So rational number system is 4 basic arithmetic operations. And rational number system has been developed around about 10,000 BC, about 3,000 years ago. So known to us about 3,000 years. The reason? About 3,000 years ago was in Asia, is dominated by Shu dynasty, right? Shunara. Shu. Okay. Shu dynasty. And Egyptian. Whatever, very important. So main purpose of the invention of rational numbers is taxation. Because you need to be able to divide land and count how many crops you can produce per year, and the king can collect the taxes. Then you need to have a mathematical formula for that, right? For example, taxation formula: 1 plus x minus x square over 2. So if you need to define functions, this is what? Addition. This is subtraction. Multiplication. Division. So if you want to have a taxation formula, you need the number system satisfies four properties. So that's the reason why around 3000 BC, about 10,000 BC, the rational number system has been developed. Then there are systems that cannot be described by the rational number system, such as an x squared is 2. You cannot describe this number by rational numbers. So x, it turns out to be square root of 2, right? The inventor of this is Pythagoras. Pythagoras, around BC 2nd century. And so this is the beginning of the new number system called the irrational numbers. So the rational number plus irrational number is called real number. The real number system has been known for almost 2,000 years. And this is basically the basics of the number systems that is used for math. And second semester, we are going to extend this number to complex numbers, but let's not do it for now. So my question is whether we can define those four arithmetic operations to the matrix. For matrix. Answer is yes. Square matrix. Square matrix n by n. The number of columns and number of rows are the same. Then we can define the four basic operations. So addition. So most of my semester, I was just covering the square matrix. And most likely 2 by 2, 3 by 3. So am I going too fast? It's okay. Little fast? Or about the right? Not too fast, right? Hopefully. Addition. Let's say A11, A12, A21, A22. B, B11, B12, B21, B22. So I'm going to introduce this particular index system. So the first index is for row. Second index is for column. So here A11, first one means it's the first row. And the second one is it belongs to the first column. So if A22 means it belongs to second row, second column. Maybe B21 is the B matrix. It belongs to second row, first column. So addition, you just add term by term. Plus minus B is A11 plus minus B11, A12 plus minus B12, A21 plus minus B21, A22 plus minus B22. Or sometimes we write A as Aij, the simple notation. So that means ith row, jth column. And B, Bij, then simply A, of course the same index, n by n, it has to be same dimension. Same dimension. Addition and subtraction is defined for the matrices with the same dimension. So A plus B is simply, you can just component-wise. So simple practice. Say A, 1, 2, 3, 4, B, 4, 5, 6, 7, A plus B. Simply, you just add 1 with 4, right? 5, 7, 9, 11. A minus B, minus 3, minus 2, minus 3, minus 3. Uh-oh. 3. Right? It's row minus 3. I didn't intend to do that. Multiplication. Say m by n, n by p. So if you want to multiply by A by B, then this index must be the same. The number of columns and of the first matrix and the number of rows of the second matrix must be the same. Yep, must be the same. So A is Aij, B is Pij, A is n by m by n, P is n by p, then A times P, Ij component, which is the sum Aik Bkj. It's multiplication formula. So my question is, can you define for this matrix PA if the matrix A is m by n matrix, my matrix P is n by p matrix. So since the number of columns for the first matrix A is same as the number of rows for the second matrix P, so we can define the matrix multiplication by this formula. My question is, can you define BA? If P and M are the same, then you can define, right? Only if P is same as M, right? And usually, even for square matrix, say square matrix, then of course it's 2 by 2. So we can define AB and BA, right? How about AB? 1, 2, 3, 4, 5, 6, 7, 8. You first multiply this, right? So 1 times 5, 2 times 7, right? So 5 plus 14 is 19, right? Second element. 1 times 6. 6 plus 2 times 8. 16. So it is 22, right? How about this element? 3 by 5 is 15, plus 4 times 7 is 28. So 15 plus 28 is 43. Very good. One last time. 3, 4 die 6, 8. 3 times 6, 18, 32, 50, right? So this is actually AIJ, AIK, PKJ, right? K is 1, 2, 2. This formula is this way. How about you change the order? PA. Five, 6, 7, 8. 1, 2, 3, 4. Five times 1 is 5. 6 times 3 is 18. So 23, right? How about second element? 5 times 2 is 10, right? 6 times 4, 24. 34. Seven times 1, 7. 8 times 3, 24. 31. Finally, 7 times 2 is 14. 8 times 4 is 32. 46. So obviously, AB, PA are not the same, right? So we say the matrix multiplication is non-commutative in general. Non-commutative or non-abelian. Oh. So when you change the order in the matrix multiplication, it's not the same in general. It's different between the number systems. If you multiply by 2 by 3, 6, right? 3 by 2, 6. So if you multiply two numbers, then they are always commutative. They change the order. But in matrices, if you change the order, the result may not be the same. There's a big difference between the multiplication of numbers and multiplication of matrices. Perhaps we can take maybe 5 or 10 minutes break. So we learned that the multiplication is not commutative. We just have 19, 22, 43, 50. 19, 22, 43, 50. But it may be associative. Associative means if A, B, C is A, B, C. So let's start with a simple one. Oh. So A times B, we have already done that before, right? 1, 2, 3, 4, 5, 6, 7, 8. Let me just double check. So A, B, C is 19, 22, 43, 50, 9, 10, 11, 12. So maybe number can be a little bit big. But let's do that. So I'm going to make it big. So this one. 19 times 9 is 171, right? You first multiply by 19 by 9. So it's 190 minus 9, 181, right? So what happens? Okay. Nine by 9, 81 plus 9, 171, right? So 190 minus 19 is 171, right? This. So 190 plus 22 times 12 is 244, right? 260, right? So if we add them together, 434, right? This is getting a little bit bigger. 43 times 9 plus 50 times 11. So 43 times 9 is 430 minus 43. 307 to 8, right? And 550, 738, 837, correct? Somebody can check with the calculator. 9? Oh, right. 9. Yeah, I must be getting old. Now, final. 43 times 10, 50 times 12. $10.30. So 171, 434, 937, 1030. Now ABC. Oh, something strange. 1030. 434, 937, 171. I think 937. So this number has been checked. It's checked. So the first two are still you need to check. So let me check if there is anything wrong. So this with this. 19, okay? Check. How about second one? 6 plus 16. 22? Okay. So this is check. How about this? 3, 4, 5, 6. 15 plus 28. 43? So at least the first part is okay. 3 times 6, 18. 4 times 8, 32, 50. So just check. So 19, 22, 43, 50. The first one, (19) times 9, 171, plus 22, 22 times 11, 242, right? 3, 1, 4, 1, 3, 4, 1, 3. So this number has been checked. And this 19, 190, 22 times 12 is 264. 454. Then all check. So we just have shown numerically that associative low holds. Wow. But I just showed one case, but it is, hopefully it works. So we can show it symbolically, Aij, Bij, Cij. A times B, Ij is K, Aij, A K, B, K, J, right? A, B, C, I, J is M, A, B, I, M, C, M, J, M, K, A, I, K, P, K, M, C, M, J. Okay, let's say N by N, N by N, N by N. then 1 to n. 1 to n. On the other hand, A times BC ij k A I k B C K J K A I K B K M C M J. So if you compare this formula, the same, right? So symbolically, if you multiply AB times C and you put component by J, or A times BC and component by J, the final formula IK, KM, MJ, IK, KM, MJ, the same, right? The symbolic formula are the same. So I first showed that this associative law is holding numerically using the numerical example, but actually you can just generally prove this property using this formula. So symbolically you can prove very easily. So we have shown that for square matrix is defined by the matrix with the same number of rows and same number of columns. The multiplication and addition, subtraction, multiplication can be defined. How about division? So I'm just going to show some symbolic, one special case, 2 by 2 first. Can I move on too fast? Say 2 by 2. A11, A12, A21, A22. Let's specify. I know the answer, but just write down A prime. A22 minus A21 minus A12, A11. And see what happens if they multiply them together. A times A prime. A11, A12, A21, A22. A22 minus A21 minus A12. A11. Let me see. Maybe I should change this into 1, 2. H1. A2, A1, A11. Let's multiply this. A11. So if we multiply them together, A11, A22 minus A12, A21. This A11 minus A12 plus A12, A11. This A22, A21 minus A22, A21. And finally, minus A12, A21 plus A11, A22. Interesting thing is, this is off diagonal, 0, right? This is 0. So we can actually combine them together with A11, A22 minus A12, A21 times 1, 0, 0, 1. Or you can interchange the order. A prime A, A22 minus A12 minus A21, A11, A11, A12, A21, A22. Is A22, A11 minus A12, A21, and this A22, A12 minus A12, A22. So actually this is 0. They cancel each other. And this minus A21, A11 plus A11, A21. This is again 0. Finally, minus A12, A21 plus A11, A22 is A11, A22 minus A12, A21 times 1, 0, 0, 1, right? So in matrix, we define unit matrix 1, 0, 0, 1. The unit matrix is like a 1 in numbers. Identity matrix. The identity matrix, if we multiply identity times A, 1, 0, 0, 1, A11, A12, A21, A22 is what? A11, 1, 0, A12, 0, 1, A21, A22, right? This is A. So identity matrix is the same as the 1. If you multiply identity matrix to the matrix, the result is the same matrix A. You can change the order too. Say times identity matrix, A11, A12, A21, A22 times 1, 0, 0, 1 is same as this is A11 A12, A21, A22 is A, right? So identity matrix number 1. So in number system, if you multiply by 1, it doesn't change anything, right? 4 times 1 is 4. 1 times 4 is 4. So the 1 does not change when you multiply the number, right? So in number, 1 is identity. In the same way, in matrix, we just found out the identity matrix, which works like identity in number. So if A11, A22 minus A12, A21 is not 0, then we can define inverse matrix as A11, A22 minus A12, A21 times A22 minus A12 minus A21, A11. Then A times A inverse by A is identity. So in matrix, you can define the division by multiplying the inverse matrix. So this is inverse matrix of A. So this is a division in matrix. So actually 3 divided by 6 can be defined as 3 times 1 over 6, right? I mean, in number division, if you divide 3 by 6, it's the same as 3 times 1 over 6, right? So 1 over 6 is actually inverse over 6 in numbers. The same way, in matrix, if you can define inverse matrix, you can define division. So as long as inverse matrix exists, we found that the square matrix is closed to 4 basic arithmetic operations, and using this property, we can define the functions of matrices. So 2 by 2 is very easy to define the inverse matrix, but it gets a little bit complicated if the matrix dimension gets higher, bigger, 3 by 3, 4 by 4. So maybe we can stop here today and continue next week. What do you think? 오늘 여기까지 하고 다음 주에 할까요? If you like that. Okay. So you learned one very important thing today, that square matrix can be closed to 4 basic arithmetic operations. That means you can define inverse matrix, at least for 2 by 2. And next week we are going to continue the discussions. Okay? A times BC. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's do this first. 5, 6, 7, 8, 9, 10, 11, 12. This. 45 with 66. So 45, 66, 1, 1, 1, right? 1, 1, 1. Next, this. This is easy. 50 plus 72, 122. 122, right? 50, 122. This 56 plus 88, 4, 4. Correct? Final 70 plus 96, 166. So A times BC is 1, 2, 3, 4 times 1, 1, 1, 1, 2, 2, 1, 4, 4, 166. The first one, 1, 1, 1 plus 288, 9, 9, 3. Let me check. Oh, I have to check every step. 5, 6. 45 plus 66. 11. Let me just continue the calculations. 1, 2, this is 122 plus 3, 32, right? 166 times 1, 2. 2, 3, 2. So this is 4, 5, 4. 4, 5, 4. This one, 2, 3, 4. 3, 3, 3 plus 4, 16, 7, 5, 7, 5, 7. So it must be 9, 0, 9. That's correct. Finally, 3, 6, 6 plus 10:30. 10:30. Oh, right. But the other 3 is wrong. So apparently, I made a mistake in either first calculation or second calculation. So It usually happens all the time in engineering problems, right? So what do? Double check. So let's start with this number, this check. So 5, 6, 7, 8 times 9, 10, 11, 12. So I have to start with check this number from the system. 5, 9, it's 45, right? 6 times 11, 66. So 45 to 66 is 111. Just about check, right? So check. Five times 10, 50. 6 times 12, 72. 1, 2, 2. Check. Seven times 9, 66, right? 63. Right. 63. Yeah. $63. 8 times 11, 88. So 1, 5, 1, right? Check. So this was right. There was error. Finally, 7 times 10, 70. 8 times 12, 96. 166. Check. So we have to check. So this has to be 151, right? So it becomes 111 plus 302. So 413, right? So we check. How about second one? 1 times 122 plus 332. So 454. So this number is checked. Yes. 333. This must be 604. So 9, 3, 8. Or 604. So it's 937. Check. Finally, this and 366, 4, 6, 664. So 1030. So this is checked. So let's try to compare with the previous one. Oh. Oh. All right.